morning, student. We learned already electric potential at a point charge. You know that electric potential, the amount of work done bringing the unit positive charge from one point to another point, potential difference. The amount of work done bringing a unit charge from infinity to that of point, electric potential due to a point charge. You know, now you have seen about the equipotential surface. Let us consider is a charge of plus q are placed here. So around the charge having the electric potential. These electric potential are same for all points in the region. It is called equipotential surface. That means if any point you consider any point or two or three points, here one point, here one point, here one point, A, B, C, D. Here same. Here also 4 points, P, Q, R, S. A, B, C, D, all points having the same electric potential, then its surface is called equipotential surface. Again, P, Q, R, S, all the points are in same electric potential, so it is also the equipotential surface, because the point B, C, D, A, all points in the same distance from the plus Q. Then P, Q, R, S, these 4 points are same distance from the plus Q. So from this distance the potential will be same for each point. So it is called a equipotential surface. See here, the electric potential at all points on the surface of the given sphere is the same. So all in the surface A, B, C, D surface, in the sphere all the points having the same electric potential. An equipotential surface is a surface on which all the points are at the same potential. So if any surface having the same electric potential, then the surface is called equipotential surface. Now see, you know the work done. What is the work done? External force applied on the charge. The amount of work done bringing the unit positive charge from infinity to that of point. So the amount of work done, you know already formula, the amount of work done W is equal to Q into V. In general formula, W is equal to Q into V into Q. General formula. Here Q, here V, the difference of potential. We want to calculate the difference at the electric potential at A is VA. The electric potential at a B is VB. The electric potential at a point C is VC. The electric potential at a point D is VD. So the difference of potential A and B, you want to calculate the difference of potential between A and B. So A minus B or B minus A. So that is a potential at a B minus potential at a. For equipotential surface, you know that the same electric potential. That means there is no difference of potential. So for equipotential surface, VA is equal to VB, because there is no any difference. A, B, C, D, all the points having the same electric potential. So should be VA is equal to VB. So apply the VB, then VA minus VA is equal to 0. So the work done is 0. So for any equipotential surface, if the charge moves from one point to another point, the work done is 0. The work done is 0 for any equipotential surface. Next one, the electric field is normal to an equipotential surface. So the electric field starting from this point, this direction, let us consider this all direction having the electric field. So the electric field will line that normal, that is the direction of electric field. So the electric field is normal to an equipotential surface. So equipotential surface ல இருந்து இருக்கிற electric fieldங்கிறது நார்மலா தான் ஃபார்ம் ஆகும். So that is a very important 2 points on the equipotential surface. So recall again. So all the points on the sphere having the same electric potential is said to be equipotential surface. For equipotential surface, the work done is 0 between any 2 points. Then the electric field is normal to an equipotential surface. But in this sphere having the different electric potential. So point at A or point at S having the difference of electric potential, but in this region the potential is same, that is equipotential surface. Now we move on, next one, the relation between electric field and electric potential. You know that the amount of working bringing in the unit positive charge from infinity to that of point, that is dx, against the electric field. So all the work done bringing the unit positive charge from infinity to that of point, so against the electric field, that is opposite to the direction of electric field, that one you put in minus symbol. So the dW is equal to minus E into dx. So the amount of work done is equal to the difference of potential. So the work done is equal to difference of electric potential. So instead of dW we put in dV is equal to minus E into dx. You want to calculate the electric field, E is equal to minus dV by dx. It is a relation between electric field and electric potential. Sometimes this equation you write another form, E is equal to V by X or V by D. So we put formula volt per meter. It already seen in beginning. For electric field having the two units, same unit, one is a Newton per coulomb, another one is a volt per meter. Already seen the formula, E is equal to F by Q. So in this expression Newton per coulomb. So the electric field expressed in the two units, one is volt per meter, another one is Newton per coulomb. Okay, now move on. The electric potential energy for collection of point charges. See here we assume that only for 2 charges. Now we want to calculation of more charges. How will you express the energy? So first you see in the 2 point charges Q1 and Q2 at the place of A and B between the distance of R. The electric potential energy is defined as the assemble to the charges, that is like charges. So you know that formula for electric potential at a point D to a point charge, single point, for expression for the Q1. So V is equal to 1 by 4 pi epsilon naught Q1 by R. You know formula work done, W is equal to V into Q2, that is another one charge only moves towards the Q1. Now applying the V value, so W is equal to V value 1 by 4 pi epsilon naught Q1 by R into Q2. So finally we get the electric potential energy we expressed, may be expressed in the W or U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. That is the electric potential at a 2 point charges, the electric potential energy on the 2 point charges. Now we calculate the collection of charges. Let us consider point A, B, C. The distance between A and B is R12. That means at the point A you put charge Q1, at B Q2, at C Q3. The distance between A, B is R12. The distance between B and C is R23. Similarly, Q3 and Q1 is R13. Now put the potential energy between A and B, 1 by 4 pi epsilon naught Q1 Q2 by R12. Potential energy between B and C, 1 by 4 pi epsilon naught Q2 Q3 by R23. B, C, R23. Electric potential energy between A and C, 1 by 4 pi epsilon naught Q1 Q3 by R13. So the total energy U is equal to UAB plus UBC plus UAC. Now U is equal to 1 by 4 pi epsilon naught taken to common, 1 by 4 pi epsilon naught Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q3 Q1 by R31. That is a final expression for the electric potential energy for the system of charges. Using this formula, you find out the of any system more than 2 points to estimate the potential energy between these two charges or more charges. Okay, thank you student. You see in next class.